The PIAT entered service during 1942. British infantry required a portable anti-tank solution. Earlier systems depended heavily on unreliable rockets. Command authorities demanded a self-contained launch mechanism. Designers selected the spigot mortar principle instead. This choice avoided complex rocket propellant logistics. The weapon designation became Projector, Infantry, Anti-Tank. The launcher body consisted of heavy steel tubing. Overall length measured approximately 39 inches. Unloaded weight approached 32 pounds. Infantry units immediately noted excessive front heaviness. The internal system relied on a powerful mainspring. This spring drove the spigot rod forward. No conventional barrel pressure was required. The bomb contained its own propellant cartridge. Upon impact, the spigot struck the bomb primer. Ignition then expelled the shaped charge projectile. This sequence created unusual firing characteristics. Recoil forces transmitted directly into the shoulder. Operators reported severe physical strain during use. Initial cocking required full compression of the mainspring. Manual effort exceeded typical infantry expectations. The procedure demanded significant upper body strength. Troops often used prone body weight assistance. Failure to cock properly rendered the weapon inert. Training manuals emphasized careful step-by-step preparation. The butt plate incorporated a thick rubber pad. This component attempted partial recoil mitigation. Field reports indicated limited effectiveness. The spigot rod remained the critical moving element. Machining tolerances required precise dimensional control. Any misalignment reduced ignition reliability. Manufacturing utilized high-grade spring steel components. Heat treatment consistency proved essential for durability. Early production batches suffered from spring fatigue. Ordnance inspectors documented premature compression failures. Replacement springs were issued through maintenance depots. The bomb itself weighed roughly 3 pounds. It contained a hollow-shaped charge warhead. Explosive filling typically used composition B. Penetration capability exceeded 2 inches of armor. At optimal angles, performance improved significantly. However, accuracy depended heavily on operator stability. The launcher lacked any sophisticated recoil buffering system. Sight alignment used a simple flip-up aperture. Effective range remained under 100 meters. Beyond this distance, the hit probability declined sharply. Backblast was minimal compared to rocket weapons. This feature allowed firing from enclosed positions. Urban combat units valued this characteristic highly. Despite advantages, cocking remained universally criticized. Reports described the process as physically punishing. Wet conditions further complicated manual compression. Mud contamination sometimes obstructed the spigot channel. Cleaning procedures required frequent field attention. The firing cycle produced a distinctive mechanical noise. Enemy forces occasionally detected the discharge signature. Operational doctrine recommended ambush engagement distances. Infantry squads typically assigned a dedicated PIAT gunner. Assistants carried additional bomb ammunition. Ammunition containers used reinforced metal canisters. Each container held 3 complete projectiles. Logistical planners calculated significant weight burdens. Transporting sufficient rounds strained infantry mobility. Despite complaints, the weapon remained widely issued. British airborne units adopted the system extensively. Glider troops valued its compact configuration. Parachute battalions trained intensively with the launcher. Field exercises exposed repeated cocking failures. Instruction manuals were revised multiple times. Design offices evaluated possible mechanical improvements. Several alternative spring geometries were tested. None provided acceptable reliability improvements. A semi-automatic cocking concept was briefly examined. Engineering complexity caused immediate cancellation. The spigot principle remained fundamentally unchanged. The production output continued under wartime urgency. Factories prioritized spring metallurgy quality control. Inspection stamps verified compression strength tolerances. Operational testing occurred across multiple theaters. North African deployments produced mixed assessments. Desert dust accelerated internal component wear. European environments introduced persistent moisture issues. Maintenance schedules were shortened accordingly. Armor penetration tests confirmed theoretical expectations. The shaped charge performed consistently against medium tanks. Angled armor occasionally reduced penetration effectiveness. Infantry doctrine emphasized flank engagement tactics. The launcher produced substantial rearward impulse. Improper stance frequently caused operator injury. Medical reports documented bruised shoulders and collarbones. Training units added specific posture instructions. Despite difficulties, experienced crews achieved proficiency. Confidence increased after repeated live fire drills. The weapon's simplicity aided battlefield repairs. Most components required only basic tool servicing. Spare springs became standard issue items. Quartermaster records tracked unusually high spring consumption. Production engineers investigated metallurgical stress patterns. Fatigue fractures appeared after repeated compressions. Revised tempering procedures improved component lifespan. Even so, cocking effort remained unchanged. The weapon never achieved universal infantry approval. However, it filled an urgent tactical requirement. Rocket alternatives remained scarce during early deployment. British command accepted the compromise reluctantly. Each procurement files recorded continued user complaints. Testing boards evaluated potential replacement systems. Several rocket launcher prototypes entered limited trials. None reached immediate mass production readiness. Therefore, the PIAT remained in frontline service. Operational feedback emphasized close-range effectiveness. Ambush teams reported multiple confirmed tank destructions. Urban combat highlighted the launcher's concealment advantage. No significant muzzle flash betrayed firing positions. The absence of exhaust plume reduced visibility. Enemy crews often failed to locate the operator. This tactical benefit influenced continued deployment decisions. Nevertheless, training time requirements remained substantial. New recruits struggled with cocking technique mastery. Instruction films demonstrated correct body positioning. Even with guidance, failure rates persisted. Some units improvised assisted cocking methods. Two-man teams occasionally compressed the spring together. Official manuals did not endorse this practice. Safety officers warned against uncontrolled handling. Accidental discharges were documented in training camps. Investigations usually traced errors to incomplete cocking. The firing pin system demanded precise engagement. Misalignment sometimes produced delayed ignition events. These incidents increased operator caution significantly. The bomb tail assembly required careful insertion. Incorrect seating prevented proper spigot contact. Armorers emphasized routine pre-fire inspections. Manufacturing tolerances for bomb tubes remained strict. Quality control rejected numerous early production lots. Despite complications, the output numbers steadily increased. By late war, distribution was widespread. Infantry platoons routinely integrated the weapon. Comparative studies examined foreign anti-tank devices. American bazooka systems showed easier operation. However, rocket supply chains remained vulnerable. British planners valued the PIAT's independence. No external propellant storage was necessary. This simplified long-term logistical planning. Still, user acceptance never became enthusiastic. Reports consistently described the weapon as demanding. Nevertheless, battlefield necessity ensured continued reliance. Post-war reviews analyzed overall performance metrics. Penetration capability met original design expectations. Reliability improved after manufacturing refinements. Ergonomic deficiencies remained unresolved issues. The future designs moved toward true rocket systems. The PIAT represented a transitional engineering solution. It combined simplicity with significant physical cost. British infantry learned to operate it effectively. Respect for its power developed gradually. Fear of its recoil never fully disappeared. The weapon fulfilled its assigned tactical role. Engineering compromises defined its entire service life. Procurement files ultimately closed without replacement urgency. The PIAT remained an instrument of necessity. Its design reflected wartime material constraints. Its operation demanded persistent mechanical discipline. British infantry adapted through repeated field experience. The system endured until improved launchers emerged. Its reputation remained technically justified throughout service. The PIAT exemplified pragmatic British wartime engineering.